Assalamualaikum, we are from Group 5. We are going to present assignment 2, Construction Technology 3. My name is Nurkalisha Nalia binti Muhammad Faizal from class PKH. For this case, we selected PPR Sungai Pinang to examine two application of in-situ reinforced concrete frame structure in residential buildings. PPR Sungai Pinang is a medium cost housing project that provides low rent apartments, and it is located in the urban area in Georgetown, Penang. This makes it a suitable example because in-situ reinforced concrete is the most commonly used structural system for housing development. The building mainly uses an in-situ cast reinforced concrete system consisting of columns, beams, slabs, stairs, and a flat roof. This structural system is able to support both vertical loads from residential use and horizontal loads such as wind. In addition, in-situ concrete construction is very suitable for Malaysia's hot and humid climate due to its durability, fire resistance, and low maintenance. Therefore, this report focuses on the selection and construction process of the in-situ reinforced concrete flat roof system used in PPR Sungai Pinang.
Assalamualaikum, my name is Nurkalisha binti Syafiee, and for this section, I will explain the type of in-situ reinforced concrete flat roof selected for the PPR Sungai Pinang project in Georgetown, Pulau Pinang. For this mid-rise residential building, the type of flat roof used is a solid slab roof. This system was chosen because it is simple, economical, and highly suitable for government residential buildings. The first justification is ease of construction. The solid slab has a simple design which makes formwork installation and reinforcement placement easier to carry out. It also does not require many highly skilled workers, thereby reducing the likelihood of construction errors on site. However, the heavy weight of slab increases the load on beams and columns. The second justification is lower construction costs. Construction costs are reduced due to the simple slab design, the use of readily available materials such as concrete and steel, and minimal maintenance requirements. Nevertheless, one drawback is the relatively high usage of concrete and steel, especially when column spacing is large. Next is the quicker construction process. The construction of a solid slab is faster because no special system such as rib or waffle slabs are required. This method is also familiar to site workers. However, construction progress may be affected by weather condition, especially when heavy rain, and concrete casting requires sufficient time for curing. Part justification is architectural flexibility. Solid slabs allow architects greater freedom in planning building layouts due to the flat ceiling surface, which is suitable for various finishes and lighting installation. But the presence of beams may result in uneven ceilings and making it less suitable for large spaces such as hall. Lastly, it is adequate for residential loads. Solid slabs are well suited to support residential life loads such as occupants, furniture, and household equipment. They also help reduce structural deflection and require only light reinforcement. However, this system is not suitable for commercial buildings such as shopping malls, which are subjected to much higher loads.
My name is Sifina Shafika, BC7 So now I'm going to explain the construction stage of an in-situ reinforced concrete flat roof. An in-situ reinforced concrete flat roof means the concrete is poured and cast directly on site, not pre-made in a factory. There are many stages, and each stage is important to make sure the roof is strong, safe, and durable. First is stage 1, setting out and preparation. This stage is all about planning and accuracy. Before any physical work starts, the construction team carefully study the approved structural drawing. From this drawing, they identify the slab size, thickness, reinforcement details, and also the position of rainwater outlet. After that, the slab layout is marked on site to show the exact position and boundary of the roof. Reference points and level are set so the slab will align properly with the supporting beam and column. At the same time, the site is cleaned and prepared. All debris is removed to make the area safe. Safety measures such as guardrails, a warning sign, and working platform are also installed. Material, tools, and equipment are prepared early to avoid delay during construction. Next is stage 2, erection of formwork. Formwork acts as a temporary mold to hold the wet concrete in place. Usually, plywood sheets are used for the slabs of feet, supported by joists, barriers, and steel props. The formwork is assembled according to the slab thickness and level stated in the drawings. Workers use spirit levels to ensure the surface is flat and even. It is very important that all joints between plywood sheets are tight to prevent seamless leakage, which can cause defects. The entire formwork system is also checked to make sure it is strong, stable, and able to support the weight of wet concrete and construction load. After that, we have stage 3, facing of reinforcement. Reinforcement bar are installed after the formwork is complete and approved. This steel bar provides tensile strength to the concrete slab. The bars are cut and bent according to the bar bending schedule in the structural drawings. Main reinforcement bar are placed along the span of the slab to resist bending, while distribution bar are placed perpendicular to help distribute load evenly. Additional reinforcement is installed around rainwater outlets and at beam and slab connection, as this area experiences higher stress. The bar are tied securely using binding wire to prevent movement during concreting. Spacer blocks are placed under the bar to ensure sufficient concrete cover, which protect the reinforcement from corrosion and fire. Finally, stage 4, inspection before concreting. Before concrete pouring begins, the final inspection is carried out. The formwork is checked again to ensure it is clean, properly aligned, and securely supported. Any loose materials or dirty are removed. The reinforcement is also inspected to confirm correct spacing, tying, and concrete cover as specified in the drawings. Safety conditions around the work area are reviewed once more. Only after the site supervisor or engineer approve the work, concrete pouring is allowed to proceed. This inspection stage is very important because it helps ensure the quality, strength, and long-term performance of the in-situ reinforced concrete flat roof. So these 4 stages work together to make sure the flat roof is constructed properly and meets structural and safety requirements.
Assalamualaikum everyone. My name is Nur Amira binti Sahari. Today I will explain the construction stages, stage 5 to stages 10 that take place during and after concreting for the in-situ reinforced concrete flat roof used in PPR Sungai Pinang. Stages 5, which is concrete pouring. Concrete pouring is the process of placing fresh concrete into the formwork of the roof slab. The concrete is delivered as ready mix and placed using a concrete pump or crane. Pouring is done continuously to avoid cool joints and the surface is leveled to achieve the required slab thickness. After that, stage 6, which is concrete compaction. After pouring, concrete compaction is carried out immediately to remove track A. A poker vibrator is used to ensure the concrete fully surrounds the reinforcement bar. Proper compaction increases the strength and durability of the roof slab and prevent honeycombing. After that, stages 7, finishing work. Finishing work are done after compaction to level and smooth the slab surface. The surface is graded and overlaid to ensure correct drainage direction and to prepare the slab for waterproofing. Proper finishing prevents water ponding on the flat roof. After that, stages 8, curing of concrete. Curing is carried out to maintain moisture in the concrete for cement hydration. This normally starts within 24 hours after finishing and can continuous for at least 7 days. Proper curing prevents cracking and allows the slab to achieve its full strength. Stage is stages 9, which is formwork removal. Formwork removal is carried out only after the concrete gains sufficient strength. Site formwork is removed first, followed by the soffit and probes. The slab is then inspected for defect before further roof work continues. Lastly, stages 10, subsequent roof work. After the concrete has hardened, a waterproofing membrane is installed on the slab surface. A cement and sand scrape is then laid to fall towards the internal rainwater outlets. This system prevents water ponding and leakage on the roof.
This sketch shows the cross-section of a reinforcement concrete flat roof. The roof consists of a 150 RC slab supported by an RC beam. On top of the site, asphalt mastic waterproofing with shelter flat is provided to prevent water leakage. Above the waterproofing, the cement and sand rendering 1:6 is laid to form a fall, allowing water to drain properly. At the edge of the roof, a parapet wall is constructed. DPC and iron flashing are provided at the junction to stop water penetration. On top of the parapet wall, a precast concrete chopping with a throttle is used to direct rainwater away from the wall. Overall, this flat roof detail ensures good drainage, waterproofing, and structural. This sketch shows the plain view of the reinforced concrete flat roof. The arrows indicate a one-way fall of the roof slab, which is designed to allow rainwater to flow towards the external gutter. Rainwater downpipes are provided at selected locations to ensure efficient drainage and to prevent water ponding on the roof surface. This roof layout helps improve water management, reduce leakage risk, and ensure the durability of the flat roof system used in PPRs. This sketch shows the formwork and reinforcement stage of the in-situ reinforced concrete flat roof construction. At this stage, the temporary formwork is installed to support the concrete until it hardens. Steel props are used to hold the formwork securely and transfer the load to the ground. Reinforcement bars are then placed on top of the formwork according to the design. These steel bars are important because they help the concrete resistance stress and improve the overall strength of the roof slab. Once the formwork and reinforcement are properly installed and checked, the roof slab is ready for concrete.
To conclude, the main objective of this study was to determine the most suitable in-situ reinforced concrete flat roof system for a mid-rise residential building, PPR Sungai Pinang in Pulau Pinang. Based on the analysis, the solid slab flat roof system was selected because of its simple yet strong structural design, which is highly suitable for residential buildings. This system does not require complex construction methods or highly scalable, making it a practical choice for government housing projects. In addition, the solid slab roof is more economical and cost-effective while still providing adequate strength and durability. The construction process involves several important on-site stages from material preparation to roof completion, all of which play a crucial role in ensuring the quality and lifespan of the structure. Overall, the solid slab flat roof system has proven to be an effective solution for PPR Sungai Pinang as it offers high structural strength, durability, and the ability to safely accommodate the loads of a mid-rise residential building.